Hi guys, and welcome to another episode of Food School Smarter, Stronger, Leaner podcast on a mission to inspire a world where food makes us better. And hopefully not just us better, but also our planet better. For us, for our future, for future generations of humans who hopefully will come after us. Guys, today is Monday and it's exciting already. Let's start this week with learning something exciting and fascinating about the future of food that awaits all of us in not that distant future. Guys, today we are talking with David Buc, the founder and CEO of Change Foods, Dairy Done Different, an aerospace engineer who is now in Australia turned cheese maker of the 21st century. This is exciting already. Guys, today we will learn about this new technology, this precision fermentation that David and his team use to make this new agey 21st century kind of cheese and other dairy products also. What's the hack is precision fermentation, and what kind of foods we can make with it. Some sort of hybrid between functional, allergies-free, and lactose-free if you wanted. Some sort of hybrid between that and personalized supplement all in one food package. How do we make microbes produce different kinds of cheeses for us without any cows involved whatsoever? Will your cheddar taste the same? And most importantly, will it melt well on our pizza? Why this new kind of cheese might be so much better than all the other plant-based dairy alternatives that I personally can hardly ever call cheese. Is this new thing good for us, for our planet? Isn't it just another version of GMO? Shouldn't we just stick with traditions of food making and stop messing with nature? These and many other fascinating questions and stories on today's episode of Food School podcast with David Buc, founder and CEO of Change Foods, Dairy Done Different, an aerospace engineer turned cheese maker of the 21st century. So without further ado, please listen to our fascinating and just amazing conversation with David Buc.
Hello, Angela.
Hi, David.
Hi, how are you?
I'm great, thank you. How are you?
Yeah, not too bad. Just sort of got dinner cooking in the background, and today's has been one of the first really warm days here in Melbourne, which is lovely. So enjoying that.
So what's the weather like now there?
Today was 25 degrees Celsius, and tomorrow is going to be 30. So we're starting to get into the warmer weather now, which is really nice.
Yeah, because it's getting into summer, right?
Yeah, exactly. Yeah, so finally, and we've luckily just come out of the COVID sort of very strict restrictions for about 2 to 3 months. We've been under very strict lockdown, and just as of the last couple of days, we've had 0 cases again. So it's been a really, really tough, for many people because it's been one of the strictest lockdowns in the world. And but luckily we've controlled that and sort of coming out of it, which is good for us. But I can see that in other parts of the world, it's coming into winter and it's the opposite occurring now. So yeah, it's very challenging.
Here in London, they're gonna start this nationwide lockdown on Thursday.
That's right. Yeah, I heard that. And we've been pretty much been under a very similar circumstance here in Melbourne. The other states in Australia have done fairly well, but where I'm located in Victoria, we had a second wave. So our whole state has been in really strict lockdown. And I think we've now been in the longest lockdown in the world. Apparently, it's been over 220 days or something like that. So it's been pretty intense for a lot of people. Luckily for me, I mean, I work from home most of the time anyway, so it hasn't affected things too much. But for many people, it was really, really challenging this second time around. So, but so it's sort of good that it's sort of warming up and, we're coming out of the lockdown. So, people are starting to cheer up again, which is great.
Yeah, that's amazing. I was actually curious, how it affected your business and everything. Some of your business is based in the US, right? But I understand like research and everything is right now done in Australia.
Yes, exactly. So luckily where the R&D has been undertaken, the initial phase, it's up in Queensland, in Brisbane, because our co-founder and CTO, he's Associate Professor Junior Teo, he's at the Queensland University of Technology. And so luckily that state has been, not very impacted by COVID, and they've been able to continue the research and it hasn't been impacted at all, which is fantastic. Apart from me being able to get up there, which has been frustrating. But, I'm not the technical person anyway. So, Zoom has worked perfectly to coordinate everything and to have our, weekly R&D meetings and speaking with Junior, every second day at least. So it's worked quite well. But I think, luckily, hasn't impacted things too much, but certainly going into next year, I'm hoping to travel and get over to the States as soon as possible. So that's a bit concerning just because of the numbers they're seeing at the moment. But, it looks like it might just have to be more of a one-way ticket for a few months at least anyway, because I think coming back into Australia is going to be an issue, unless I quarantine and everything every time. So I think it'll be, more of a longer-term sort of, trip over there. That's the situation at the moment, unfortunately, that we're seeing, and but hopefully in the new year we'll see what happens over the winter in the US. Hopefully after the elections, and we'll reassess and see where things are at that stage, and hopefully I can get over there.
Yeah, hopefully you will get over there, and do everything you want to do. And but it's great to hear that where you are right now, everything seems to be getting better.
Exactly.
That's great to hear. And David, how do I pronounce your last name?
BUCCA.
BUCCA. I like Italian pronunciation, right?
Exactly. Yeah, my parents are Italian. Yep, exactly.
Okay, cool. Yeah. So David, officially welcome to Food School podcast. It's amazing to have you here because the mission of this podcast is to help people to understand food better and make better choices. And you are working with this innovative product or line of products that a lot of people just don't understand what it's all about. And so hopefully after this, podcast, they will understand it a little bit better. And maybe when they're able to buy your product, they'll be more likely to give it a try.
Yeah, absolutely.
So David, you worked for Boeing for 13 years as an engineer, and then you transitioned to food industry, hemp based products company, and then plant-based meat. So how did it all, come to be, and how did you get to where you are right now with new kind of dairy products?
No, it's a great question. And you're right. My career and my whole, experience so far has been mainly in the aerospace and aviation industry, even actually getting my commercial pilot license back when I was at university, and but ended up choosing a career in engineering, and have worked, for most of my career at Boeing here in Melbourne, Australia, and also a little bit overseas as well for a couple of other aerospace companies. But really, doing many different functions from engineering through, manufacturing management, and then ended up in quality assurance, and sort of doing things like sort of continuous improvement initiatives and being one of the internal auditors at Boeing. So very steeped in that industry, and it was a big surprise to a lot of people when I really wanted to make a switch a few years ago. I think it's about 4 or 5 years ago now, when I really sort of learned a lot about the issues that we're contending with globally, from climate change, human health and nutrition, and all the issues associated with our diets, and of course the ethical treatment of animals. And really, when I looked at the center of all of that was the industrialized animal agricultural sector and its large part contribution to a lot of these global issues that we're contending with. And then on the other hand, being a very sort of innovation and sort of technology-based person, I could see that there was this rise in food technology and innovations that was really exciting. And this marrying those two things together, I could see that this new technology could be a real true solution and contender to actually produce food in a way and solve a lot of these issues. And so when I really joined those dots, it was like a bit of an alarm bell to me, and I actually became plant-based or vegan sort of overnight. And, the big shock to all of my friends and family, because I'm sort of coming from an Italian background. I used to eat a lot of meat and dairy. But really, it was just a new trajectory for me personally. And then, of course, for my career, because, I just knew I wanted to be part of that solution and help do what I could to accelerate and work in this food technology space to, bring products to market as soon as possible, in hope to really sort of bend the curve on these issues that we're facing globally as quickly as possible, and just try and be part of that solution. So suddenly aerospace actually felt a little bit insignificant, believe it or not, as a consequence. And that really, led me to figure out how to move into food. I was fortunate enough to meet a fantastic young, high-achieving gentleman called Thomas King here in Melbourne. And we basically both started a not-for-profit organisation called Food Frontier, which is Australia's and New Zealand's sort of industry think tank and accelerator for alternative proteins. And that was really set up to help accelerate this whole movement as best as we could, certainly in this part of the world, and get Australia collaborating and to create a bit of an ecosystem here to foster this new innovation. And because of that, I learned a lot about the industry, sort of travelled to the US in 2017 and learned a lot about the technology and the companies working in this space, and really just wanted to absorb myself in that sort of, that space for as many years as possible, to really sort of learn about the gaps and figure out where Australia can play a role in certainly supplying a big demand coming out of Asia over the next 20 years, because the per capita meat consumption is increasing, and there's going to be 9.7 billion people by 2050, and we've got to feed that population. And of course, because of how inefficient our current food systems are, would need two planets to feed the one, but we've only got the one planet. So of course I could see that something revolutionary had to change in the way that we produce our food. And I think that this technology is a real contender to do that. So so that's pretty much what led me to learn about this alternative protein space and to look at all the different opportunities. And I knew I had to move into food. So I sort of left Boeing and became the COO of a hemp food startup here in Australia, which really helped provide a good baseline for me to learn about food industry and to work with logistics and operations and manufacturing, as well as getting, right through on shelf with the major retailers here in Australia called Coles and Woolworths. So really learned the whole value chain of the food system. So it was a perfect stepping stone for me to transition into food. And as of the start of last year, I've also helped a US plant-based meat company called Hungry Planet as their APAC regional manager, just to help them sort of look at co-manufacturing options here in Australia, as well as be their key accounts manager and work with sort of distribution here in Australia, Singapore, and the wider Asian area. And really, this whole time, it's been an exploratory journey for me to figure out, what do I want to do? So when I was looking and really assessing all of the opportunities in this space, what really stood out to me and what I got excited by the most was precision fermentation, which is a type of specialist fermentation that I think will really revolutionize food over the next 20 years, just because of where the technology is at right now, and its cost structure is sort of reached a point where it's now starting to be quite competitive in food. This particular technology has been used for over 30 to 40 years in other industries and other applications, as well as in food, but more as a processing aid in food products. For example, non-animal rennet that's used in cheese making. 90% of cheeses made worldwide use non-animal rennet, and that's also produced via microbial fermentation. So, we have been consuming products using this technology for a long time, but there really hasn't been a key demand for it until now for it to be actually applied to direct food products. And so I really got excited by that. And also just dairy in general, I think, is just a massive kingdom of foods. And whilst there's been a massive acceleration and surge of plant-based meats and alternative meats, certainly since about May last year, when Beyond Meat, an American leading company in that space, sort of had their IPO, and was hugely successful, and the whole investor community worldwide really started turning their heads and paying attention to the opportunities in this space. And since then, there's been a proliferation of many other startups and brands moving into this territory, which has been fantastic. But really with dairy, especially cellular-based or fermentation-based dairy alternatives, I think was always very limited. And I think there's a huge market and gap still for more companies to work in that space, because I think precision fermentation is the perfect application of that technology for cheese and dairy in particular.
Yeah, we probably, most of our listeners know that things like yogurts or kefirs or cheeses, they are made by fermentation. Certain organisms ferment the whatever they're given, and we have like the final product. So, how is precision fermentation is different from regular fermentation that we've been using for like centuries?
Yeah, you're exactly right. So, traditional fermentation has been used for, actually millennia, I believe, and for transforming many different foods into end products that we've come to love over generations and history, including, cheese, like you've mentioned, and wine and beer and a lot of other things as well. But really where precision fermentation is different is, whilst it's still fermentation, it's precision fermentation because you can precisely control the inputs and the outputs of the fermentation process. And so in particular with things like, yeast that's used, for example, in making bread, if you look at baker's yeast, you ferment it with sugar and you produce carbon dioxide to leaven bread, or, with brewer's yeast, you're fermenting yeast with sugar to produce alcohol, for beer and wine and so forth. And so in a very similar way, we're using yeast or other microbes like fungus or other filamentous fungus or even bacteria. But then you can basically genetically code that microbe. So when you ferment it with sugar, it actually produces something that you're looking for. For example, in cheese and dairy, we're very interested in casein, which is one of the key proteins, which is very difficult to replicate in the plant-based world, and which is why this technology fits so perfectly, because we can just take that modified yeast or fungus and ferment it in a very controlled and precise manner to then produce that specific compound of interest.
And you don't need, in this specific case, to ferment or create a new dairy product, you don't need any milk or anything coming from cows, do you?
No, exactly. So the way to think of it, and I find this really fascinating, but really, a cow is, in a very draconian and industrial sense, it's just a metabolizing, organism, really. It's a macroorganism. So if it eats grass, and really what they're interested in is the milk. But of course you have to raise and grow a whole cow in between that process to do that, right? And so if you think about it, it takes 2 to 3 years to grow a cow. And of course a cow is growing a whole body. It's eating a lot. It's excreting a lot. It's, putting a lot of gases into the ozone. So, and of course it has to be given a lot of antibiotics. It has to be reared and raised and impregnated every year. And so it's a very, hugely inefficient system, which is why there's so many byproducts from the dairy industry just for it to be profitable. I mean, you have to think about, what can they do with the entire carcass of the cow, all of the other byproducts, they have to basically profit from to make it a viable business. And so really when we're replacing the cow, the macroorganism, with another metabolic organism that is way more efficient, which is basically a microorganism, which is the yeast or the, or bacteria. And so really, in essence, you're still feeding it grass or cellulase or sugar, but it's producing the same exact compounds, but obviously without raising an animal. And so you're just removing the cow from the equation, but you're still producing on a bioidentical level this exact same proteins that you find that are very important for making dairy. And of course, once we produce, for example, that specific protein, or in our case, we're doing proteins and fats as well, then you can actually formulate them with other, plant-based ingredients into finished products. So effectively, we're like building the Lego blocks of food, and then we can reassemble them with other foods and ingredients to create the end products like cheese or yogurt or ice cream that we're looking for.
Okay, I see. I think I understand now better, how it's all made. The thing I'm fascinated with the most, I think, is the precision part. As I understand that, maybe not right now, but in the future, you'll be able to, code those microorganisms to create a certain amount, of casein or lactose, or certain maybe amounts even of vitamins like vitamin A or B2. Am I correct here? Or
yes, yeah, exactly right. Yeah, exactly right. So you can change that microorganism and code it in a way by inserting the right DNA and genes into that microorganism to actually produce whatever specific compound you're looking for. In this case, for dairy, obviously we're looking for the key functional proteins and lipids. But yes, you're absolutely right. I mean, you can create other types of high value compounds and nutrients and things that are used as even processing aids, enzymes, all types of things, and including even gelatin or basically collagen, which is used in gelatin, for example, and things like that. So there's a huge, and this is why I think it's really going to be revolutionary in so many ways. And the reason I've called the company Change is because whilst we're changing foods right now and starting with dairy, really the future is endless in possibilities of what else we can change. So one day we could change leather, or one day we could change cosmetics, or one day, and basically by using microbial fermentation as a vehicle, you can really then use the same technology baseline process, but then redirect it to other applications. And, very recently, for example, some other startups are looking at recreating honey, honey using microbial fermentation and basically producing the exact type of honey. You can even use it for things like materials and biomaterials and things like that, synthetic fibers and fabrics. There's a company looking at spider silk or spider web material that can be produced by this. It could be used even for wool and other sort of animal-based products as well. So it's really endless in terms of its applications and use.
Yeah, I think the sky is not the limit. It's only the things that we can think of now, but in the future we will think about other million things.
Totally.
Exactly. I'm a nutrition coach, and for me, this is personalized nutrition plus supplements taken to another level. We will be able to actually program or code our food to have specific proteins or nutrition profiles to, help people to improve certain functions of their body. So that's why it's also really fascinating for me.
Totally. Yeah, exactly right. It's sort of it's called additive manufacturing. And this is the beautiful thing about, this technology is that once again, you're building the Lego blocks that then you can assemble into different end products. So it's a bottom-up approach. And the beautiful thing about that is then it can be highly customized. And so, for example, with cheese, we can build it and formulate it in a way that's very important, or what the consumers are after at that point in time. But in future, that could change, right? So we could change the lipids profiles to be more omegas, for example, or you could bolster the nutrition. You could add more antioxidants. You could add prebiotics and probiotics into the formulation as well, all using this sort of similar technology, or just even conventional technologies. But it allows that highly customizable function, which I think, is really exciting, because like you said, it's sort of endless then in terms of the possibilities for it to morph and change and update with more and more information and science as time progresses.
And plus, it's amazing for people who have different digestive issues or, sensitivities, allergies, it also can be customized for them.
Correct. Yeah. I mean, because once again, we're formulating it and customizing the end product. So we're obviously reducing or removing altogether the lactose, and the sensitivity in terms of allergenicity can be, dialed in or even engineered out of the product potentially as well. And so, you can effectively, over time optimize these products and the properties that they contain to really sort of target specific consumer needs and things like allergies and even sort of carcinogenic properties potentially. I mean, there's lots of different things with more and more science that we discover that we can start building into the outputs of these sort of products and technologies.
Yeah, and I also, love that you are mentioning that this is, possible future. So a lot of people, when they see like the first iteration of any product that might be, not as good as they expect, kind of give up on this, like, or, natural thing is better. But then we like in the future, it will be much better and better than, nature created. And we just, got to be a little bit more patient and
Yeah, totally. I mean, this is something I've learned very heavily from the aerospace industry, and it's really this mindset of continuous improvement and also building in the type of culture in your company that is basically the best at getting better. And I think that's something that I've always lived with and taken away, certainly from the aerospace sort of culture. And I think that is, truly exciting and what I want to build and certainly build into the culture of Change Foods as well is really just that continuous improvement approach that you have to start somewhere. And this is the first time this technology is really going out to the masses and being commercialized, certainly in food applications. And so it's just endless in terms of the iterative process of how it can get better. And so really setting up the right sort of feedback loops, working with very heavily with customer feedback and sort of being really adaptable, I think is hugely important for these type of new technologies, because it is very foreign for a lot of people. And I think there's a huge educational piece that has to go hand in hand with bringing these type of products to market, because when you actually break it down and explain it, it's actually pretty simple in regards to the fact that, we're already consuming products using this technology. It's just that we haven't really paid attention to it or really questioned it in detail. And so now we're really just sort of trying to explain that to people, because there's a higher level consciousness of people wanting to understand where their food comes from, which is fantastic. I think that's something that we should all question and understand. And I think that's also an opportunity for this type of technology over the years to come to really sort of educate the market and explain that it's really just taking food to the next level and bringing it into the 21st century and beyond, where we can just look at our systems and rather than just sort of take a process or that we've used for hundreds or thousands of years, like conventional animal agriculture, and really start questioning and sort of saying that well, where are we at today and what can we use in terms of our scientific knowledge that we've learnt to really sort of create the same products that we've loved and grown up culturally to consume, but really just in a much smarter way. And so this is where it's really sort of entering a new era of sort of out with the macro and in with the micro. I think there's a huge opportunity there, including with cell-based meats and all these other technologies that are emerging now as well.
Yeah, like you mentioned also education, and I think a lot of people feel a little bit weird imagining themselves, consuming all these new products. But a lot of people also don't realize that, for example, if we take regular yogurt that we buy these days in our supermarkets, most of them are already made using bacteria that was engineered using CRISPR.
Right.
Yes. So people just don't realize that our food world has already changed.
Totally.
Yeah,
Yeah, no, totally. I mean, even if you just look at something that's conceivably natural, just like meat, right? Yeah, there's always a big argument that meat is natural and all of these other products like plant-based meats are unnatural. But really, when you actually start questioning the process of what that meat went through to get to a consumable end product, I mean, it's very there's a lot of steps involved, just sort of in terms of raising the animal, and what the process needs to get to a consumable state. And I think we just are so separated from that as a consumer that we don't really see it up front. But you're absolutely right in saying that we have to question how natural our current products actually are when you think about all of the processing that goes into raising an animal and obviously processing that animal to get to a finished end product.
Yeah. And, speaking about the process, I'm sure listeners are curious about, like, in layman terms, how exactly this process looks like to make your new dairy products, cheeses or maybe other products. Like, what do you take? And what do you add to it? How you change it and how it becomes the end product.
Yeah, sure. No, it's a great question, and it's just three key steps. The first step is just to take a microorganism, once again, like a yeast or a filamentous fungi or bacteria.
Where do you take them? Where do you get?
There's lots of wild strains of yeast all around us everywhere. So it's pretty much just getting them from culture houses. For example, I mean, in cheese making right now, they're using many different strains of yeast and fungus and of course bacteria in the cheese making process right now, right? So if you look at the conventional cheese making process, you're taking milk, raw milk, you're adding sort of lactic acid bacteria to that to start the milk fermentation process to eventually create a curd, with other coagulating agents like non-animal rennet. And so that curd then separates from the whey, and then you take that curd, which is effectively the matrix of proteins and fats and the flavors and compounds, and then that's what sort of then ultimately turns into cheese, and which they use other sort of bacteria or ripening microbes as well, in which basically allows it to ripen into different cheeses that we love today. And so when you look at that cheese making process, it's effectively very similar, because we're taking yeast, wild yeast, from culture houses or harvested from nature, and you then genetically modify them to, once again, you're tweaking the genetic code of that yeast to express different types of outputs. So then when you ferment it, which effectively is the second step, you genetically modify these hosts, these microbes. You then enter the fermentation step, which is effectively just fermented with sugar and sort of nutrients in terms of a ferment, but in a very controlled manner, which is where the precision fermentation element comes in a very clean environment. And then the third step is that basically, you have to purify that specific compound that you're looking for away from the ferment, but it's all sort of, you basically got a biomass at the end of the fermentation that you purify, and you get your key compound that you're looking for in the case of a protein or a lipid. And then you formulate that once again with other plant-based ingredients, into your finished end product. So that's pretty much the entire process. And
what do you use to coat, out of curiosity, those yeast initially? Like, what technology? Maybe it's something people are familiar with.
It's called. There's different ways to do it, but it's effectively, it's called recombinant DNA technology. So what that means is you're effectively taking genes that originally started from a cow, which code for basically for it to produce that particular compound, like casein, for example, and then you insert that DNA effectively into a plasmid, which then basically you insert into the host microorganism. So it's a very proven technology. Once again, it's been used in biofuels and medicine and sort of for many years, and it's basically called recombinant strain engineering. And so that's effectively the process. There's other possibilities like CRISPR, for example, and other sort of DNA editing technologies. But in this case, recombinant technology is effectively the mainstream sort of process used initially for this process.
Yeah, it's pretty straightforward process when you think about it. Just a few steps, but they're quite scientific.
There's a lot of micro steps in between.
Yeah.
That's for sure.
For sure.
At a high level, that's sort of the main steps. But of course, each, for example, milk and dairy is actually very highly complicated. And a lot of people think that milk's quite an easy process. But when you break down milk, it's one of the most complex
Foods,
sort of liquids and processes known. And because if you think about milk, it's really a substrate of a liquid whey protein and nutrients in a broth, if you like. And then interdispersed in that broth is fat globules, which is also a very complex sort of compound, as well as casein nacelles. But then when you look at a casein nacelle, which is effectively just like a bundle, a little clump of casein protein, that's sort of, when you break down that nacelle, there's actually 4 other types of casein within that. So there's an alpha-S1 casein, there's an alpha-S2 casein, there's a beta casein, there's a kappa casein, and they've all got slightly different properties. 3 of them are hydrophobic, which means that they clump together, but they're surrounded by the kappa casein, which is hydrophilic, which is what allows it to be suspended in the milk substrate. And so when you actually start breaking down milk, it's actually extremely complicated.
Listening to you made me realize that even more.
Yeah, exactly. And so, of course, when you use a sniper rifle like precision fermentation, which is very controlled and specific to one particular compound, then actually it can get quite more complicated, because then you have to use potentially a different process for producing an alpha-S1 casein versus a different process for producing an alpha-S2 casein, and a different. So, whilst it's very easy at a top level, there's a lot of sort of detail that underpins that, depending on the specific things that you want to create. But I guess that's also the beauty and the opportunity in using this sniper rifle of precision fermentation, because you've got that high level of accuracy to pinpoint exactly and produce precisely the compound that you want to do and create. So then it's very controlled, and then it will allow for high levels of customization and product at the end.
And so as I understand it, besides all the nutrition stuff, you can make it into any kind of cheese and probably any kind of dairy product at the end.
Yeah, exactly. So, really, you can use precision fermentation to create, once again, those specific compounds. And then the second part of the process is the formulation part. So the formulation part is effectively bringing those compounds together with other ingredients to assemble them into the final end product. So, for example, cheese. Once again, if you think about the cheese-making process, you're separating the curd from the whey. And the curd is mainly casein protein, because the whey is the other main type of protein found in milk, which is what you're separating from the cheese in the cheese-making process. But when you look at something like yogurt, for example, well, then you've got intermixed casein and whey together with some of the fats as well. And of course, because of the fermentation, there's different flavor profiles that evolve during sort of yogurt baking. And so really then it depends on what product you're specifically targeting. That will then dictate exactly, what compounds you need to produce, and then what you need to do in the formulation piece to bring that together.
Yeah, and can people buy it now? Like the cheese?
Well, yes, actually, Perfect Day is one of the market leaders in this space. They've been, they started up in 2014 and have been pioneers, really sort of, defining and using this sort of technology specifically for dairy. And, they've initially I guess focused and really brought to market their whey protein. So they've helped develop some of the initial whey proteins, and they've actually showcased that in some of their ice cream, which they've recently brought to market. They did a trial run last year under their own brand, and now they've got a brand called Brave Robot in the US that is really showcasing their non-animal whey protein in fantastic different array of flavors and ice cream. So yes, if you're in the US, you can actually find locations to try the first application of this technology in market, which is really exciting. And of course, we're busily working to try and get some cheeses using similar technology to market over the next couple of years.
Yeah, and I think one of the amazing things about this kind of product is it's also not just really precise, but also much better. Well, at least how we design it to be much better for the planet. And there are no cows will be involved. Also, there are not going to be like antibiotics or other possible substances that people are worried about trying to buy organic or grass-fed, and so that completely eliminates that cow's step, bringing something healthier for us and for the planet.
Yeah, totally, exactly. I mean, that's one of the main reasons I'm doing this, is just because of all of the positive impacts that this sort of revolutionary process can have, while still providing the exact same experience as an end product. You're doing it in a vastly more efficient process, so without raising a cow, once again, 2 to 3 years to raise a cow, this takes a matter of days, to create a culture and to ferment it to produce the compounds that you're looking for. So days versus years, and because of that, you're not raising a cow that has bones and tissue and skin and has to eat and has to digest and has all of the bodily functions that come along with just really harvesting milk, right? Which is all effectively waste from a process point of view. I mean, from an aerospace point of view, you would call all of that waste. And so, when you're trying to lean out a manufacturing process, the first, and lean manufacturing is, I guess, the relentless pursuit of eliminating waste from a process. And so when you break it down from a process point of view, effectively, 95% of the process is waste, because you're just trying to harvest, one particular compound of interest, which is milk. And so that's where the opportunity lies. So really, using the best of technology and what we know of today in science to, once again, use that sniper rifle to produce that specific compound without all of that, waste that comes along with it. And because of that, suddenly, the opportunities, become apparent. So, it takes up to 1,000 litres of water to produce 1 litre of drinking milk, liquid milk. And then when you look at cheese, for example, a cheddar cheese, it takes 10 litres of milk to produce 1 litre or 1 kilogram of cheddar. So then you can compound that by 10 in cheddar cheese, right? So it really starts adding up, and 1,000 litres of water is 2 months worth of average showering. So to drink 1 litre of milk, it can take up to 2 weeks worth of average showering of water. And that's just water. I mean, then you look at land use, you look at greenhouse gas emissions, and there's been many reports, obviously, and things, been quoted a lot, I guess, from the alternative protein industry that, if you look at animal agriculture combined, the greenhouse gas emissions emitted add up more to the whole global transport sector combined, which is pretty remarkable when you think of it that way. And of course, there's many solutions to helping us, and there's lots of improvements being made in agriculture and farming practices, which is also part of the solution, and that's fantastic. I mean, there's a lot of technology and innovation going into feed, feedstock and to really sort of reduce the amount of carbon emissions that's occurring. So that's fantastic as a transitional process. But at the end of the day, we've got to make drastic change as soon as possible. And I think that's where this technology, and by accelerating these solutions, which are just 98% more efficient, I think that's where you're going to get the most impact in the shortest amount of time.
Yeah, because, it's one thing to maintain, certain amount of people that we have now and had before. And then it's going to be completely another thing when we have like a couple of or 5 billion people more on the planet.
Yes.
And at some point, it's just not going to be a possible reality to grow all these animals to just make food.
Correct.
for all of us. So that's, an amazing, I believe, mission and vision. And thank you, David, for being the one who is moving it forward too, among many others. So tell our listeners, what's your long-term vision, mission for the company, product line maybe, and also when are you planning to, have your first products on the market, maybe US or Australia, and what those products going to be? Those first.
Sure. No, thank you, Angela, first of all, for all of those comments. And look, really with Change Foods, once again, it's a brand that has a big vision. And I think whilst initially we can use this technology to make the biggest impact in certainly in dairy and other types of foods, I mean, where this technology can morph into and progress into is really quite exciting to me. I'm a big fan of really looking at the leather, the alternative leather space as well. And I think this technology can certainly go a long way in terms of recreating leather and leather products and really revolutionizing fashion and other applications of leather. And I think that there's huge potential for that. Gelatin and cosmetics and supplements, all of these things which once again have been, really if you look at sort of the byproducts of animal agriculture, they're ending up in all of these areas for a number of reasons. And I think this technology once again can be used to displace a lot of these inputs, given that there's no need to have those sort of products in there. So really that the long-term vision is bright. I think once again, there's different applications using the core systemic process of, precision fermentation, but basically other biotechnology to sort of reinvent or basically recreate the animal products that we love, but without the ethical, environmental and other issues associated with farming animals. That's effectively the vision.
And what about a short-term vision for your company and products?
Sure. Yeah, absolutely. So we're basically, we're focused on the US market initially for our product launch with cheeses. So really sort of looking at some of the harder and cheeses that we've grown to love. Over the next sort of 2 to 3 years is when we're planning on going to market. So by at the earliest, the end of 2022 or start of 2023 is hopefully when we see our products starting to hit, I guess, some of the shelves in California, certainly. In the next sort of 2 to 3 years, and then closely followed by, I guess, expansion domestically throughout the USA, and then also closely followed by Australia and Singapore and going into Asia. The beautiful thing about this technology as well is because it's got such a short production cycle, once you've scaled at an industrial scale and you've developed really clear standard operating procedures, it can be then localized quite easily into other areas. And so working with industry partners and developing the networks that we have here in Australia and certainly in Singapore and some other Asian markets, there's a huge opportunity to then, take this technology and start producing, these compounds of interest in these local markets. And then once again, formulating them and customizing those products, specifically geared to those markets, because cheese is different everywhere. And that's the beautiful thing of cheese is its cultural significance into so many different countries and cultures. And I think, by being able to customize the end product, we've got the ability to formulate and create things specific for those markets. So, 2024 and beyond, we're hoping to start our first production runs in the APAC, Asia Pacific side of the world. And then get into yogurt, I think is probably our second product line of interest. I think it's got a big, use certainly in Asia, more so in cooking and in different types of cuisine. And it's just it goes very well with sort of the whole fermentation side of things as well. And the beautiful thing about precision fermentation is it's, based in fermentation. It's something that people, have grown to like, and it's certainly a trending, subset of nutrition and health foods, which is fantastic. So, we can certainly, and that's why, I think yogurt is one of the fastest growing categories in that space, including drinkable yogurt as well, which is really exciting. So there's certainly areas of interest for us to expand into fairly soon after cheese.
Yeah, that's why I actually reach out to you. Fermentation, you probably can make like almost everything, like it seems to me, fermenting stuff. Most of the
Sure.
foods I love are fermented, like coffee or
Yeah.
chocolate or
Yeah.
kefir
Yeah.
or sauerkraut.
Yeah. There's something magical about fermentation, right? Because it transforms food. And I make a lot of sourdough bread, and I've just amazed at the fact that it's just flour and water on day zero, and then within 7 days you've got a starter culture purely from harvesting the wild yeast that's around us
Hmm.
in our environment. And I think that to me is just magical, and there's just something that we can't
Exactly.
see that is happening all around us everywhere, in our microbiome. I mean, we're just scratching the surface now of really trying to understand microbiology and its effect on ecology on so many different macro and micro systems, that it's just hugely exciting. I think the future in terms of gut health, nutrition, and the applications of fermentation in so many areas.
Yeah, without microbes, we ourselves and our planet, we just not,
Yeah,
we wouldn't
totally.
exist.
Totally. Exactly.
And for me also as a health nutrition coach, what I do, I always first and foremost I pay attention and trying to optimize for gut health, because
Yeah.
we have more of those guys in our guts than our human
Yes.
cells, and if they're not
Yeah.
healthy, we're not going to be.
Totally. Yeah. Yeah. Once again, I think there's just so much to learn around the microbiome and its impact on human health. It's just remarkable. I've heard so many podcasts of leading experts in this space just saying that we're scratching the surface of really understanding the biodiversity of our gut, and what that does for our inflammation, for so many biomarkers, and things that we just take for granted. And of course, eating a variety of foods and increasing our biodiversity of different types of plants will help build a healthy gut flora. And it's just it's hugely important for good health. And we're just really sort of learning that now.
Yeah, exactly. Well, David, it's been really a fascinating conversation. I learned a lot, and I'm sure our listeners learned a lot too. And now they're going to be looking forward for that change foods cheese that
Yeah.
has nothing to do with cows.
Yeah, thank you so much, Angela. It was really lovely chatting
And
with you. And yeah, thank you.
David, is there anything else you'd like to share? Maybe, I haven't asked a question that you wanted me to ask. Anything else you'd like to share with listeners?
Oh, look, not really at this point. I think we've covered so much ground. I think I've sort of certainly talked about all that I need to talk to in terms of what we're up to. I mean, to me, it's I guess the biggest takeaway is really just that it's an exciting time, and I think we shouldn't really be scared of trying different things and starting to question and where things come from, and really trying to understand the impacts of the choices that we make every day. Every time we buy something, we're voting for something. You're contributing to a system, and the consumer consciousness is certainly increasing, and people are starting to wake up and realize the impacts that food has in our world. And I really encourage people to educate themselves, to learn more about where their food comes from, understand the food system and its impacts and how it really deeply works. Because when I did, it certainly changed my whole life perspective, and once again enabled me to change my whole career to help support this, because I just couldn't believe the contribution that some of these things that we just take for granted is having on the world. And I think I really encourage people to think about it deeply, and to educate themselves, and then try new products. And I think it's just so exciting. There's so many startups emerging, and food is very personal. It's something that we all love, we've grown up with, and it's just like we're now entering this whole new era of new foods and flavors and technologies that we've never tried before. And I think that's just hugely exciting. So yeah, that's pretty much it.
It is exciting. And again, thank you for sharing this message, for creating this new product and affecting, now and in the future, so many more people, us, eaters, consumers. Thank you, David, for that. So David Buc,
Pleasure.
you're founder and CEO of Change Foods, Dairy Done Different. So where would you like people to go to maybe learn more about your company, what you're up to, where people connect with you?
Look, our website, I guess, is probably the first starting point. It's pretty much bare bones at the moment, but there is a survey that we have put on our website and we've had up there since effectively day one, which we encourage as many people as possible to take. It only takes literally 2 to 3 minutes to complete, but we're keeping it there as a long-term survey to really deeply understand our consumer motivations and to understand, consumer pain points and what they'd love to see as well in terms of foods and technology. So I certainly encourage you to go to our website and please take that survey, and really just follow us on all the typical social handles.
Mm-hmm.
We're on Instagram and Facebook, and there'll be more and more and more content coming out over the coming weeks and months. And whilst we're not commercializing product for 2 years, we're actually using this as a huge opportunity to really educate our consumer base and put out some pretty cool and interesting content to explain this tech and to really sort of lift the veil on this potential with this technology. So I encourage you to please follow us on social and stay tuned for the updates.
Yeah, thank you, David. I'm going to link everything that you mentioned in the show notes so people can easily, follow you and take the survey and learn more about your company and your mission, product. So thank you for sharing all of this, telling us about your mission, your new products, and sharing your mission short-term and long-term. So thank you, David. Really appreciate it.
Absolute pleasure. Thank you so much, Angela, once again. Much appreciated.